Okay, kiddos. So today we are going to work on this lab, and unfortunately I didn't feel like we could do it all at the tables and get stuff cleaned and put up. So I'm going to show you kind of how it's supposed to go, and then I'm going to give you some other ones to work on. So first off, we see the packet talks about half-life, and I probably already read that to you in class. Our materials are the 2 beakers, one filled with 400 milliliters of radioactive substance, and we're going to say that our radioactive half-life time is 30 minutes. Okay, and we need the 3 graduated cylinders, and we need our beaker B to put our new element in. So mark 1 beaker A. There's a paper that helps me keep them straight. Beaker A and beaker B. And then it says to fill one with 400 milliliters of radioactive element X, so that's just water, and place 2 drops of food coloring into beaker B. Okay, so there's our half-life time, not 30 minutes, we're gonna make it 30 seconds, pardon me. So to illustrate each half-life, we're going to use the appropriate graduated cylinder to best measure off half of the radioactive element. Okay, so we're going to graph our data as well. So we're going to put our time passes here: 30 seconds, 60 seconds, 90 seconds, 120 seconds, 150 seconds, 180 seconds. I hope that's right. Sometimes my math isn't. Okay, and then we're going to say at each half-life how much radioactive element we have remaining and how much of the daughter element we have. Okay, so I'm going to undergo my first half-life. There's 400 milliliters of this radioactive element, so I'm going to pour off 200 milliliters carefully in the graduated cylinder. So there's 100. It's going to be my new daughter element, and that's 100. We need 200, so we're going to pour off another one. And 1 half-life has gone by now, and we have 200 milliliters of our radioactive element, and we have 200 milliliters, roughly, of our daughter product. Now, tick-tock, tick-tock, time has gone by, and we'll do the graphing when we're all done. I'll probably do that with you in class. Okay, so now we need to take another half-life. So half of this material is 200, half of 200 is 100, correct? So using the appropriate graduated cylinder, and pouring that into our daughter product. So now, after the second half-life, we have 100 remaining because half of 200 was 100. And of our daughter product, we have roughly 300. Now, tick-tock, tick-tock, time is going by again, and we're going to take half of our radioactive element again. So half of 100 is going to be 50. So we could use the bigger one, or we could use the 25 milliliter one twice. So it's just preference. I'm gonna think I can eyeball the 50 mark on here. Let's see if I can do it. It's about right there. So now we have 50 remaining, and this is our new daughter product. And we should have 350 because we just took off 50. So you can see, oops, sorry, you can see our document now, what our table looks like. Now, time goes by again, and we need to take half away from 50, so this time we probably do need the smaller one, the medium one, and to take off 25 milliliters. Because half of 50 is 25. I find this one a little more difficult to work with. Okay, 25. So taking away 25, adding it to our daughter product. So half of 50 is 25. We have to take that 25 that we took away and add it to our 350. So what number is that going to be? 375. Somebody get that, will you? Okay, now we have 25 remaining. So what is half of 25? Okay, right. So we have to take away 12.5. So this one's going to be a little more trickier. This goes to 10. So we're going to pour off 10. I hope you're seeing okay. Carefully pouring off 10. Okay, there's 10. And we're going to have to pour off 2.5 more to get the, I don't think I can lift it and do it that time. It's way at the bottom. Oh, I did it. 2.5. So now we have 12.5 milliliters, and we add that 12.5 to our daughter product.